When I modeled this structure, this disorder, I just concentrated on these two atoms and I ignored the slight elongation of these rings here, and it looks like maybe this phenyl ring isn't ideal. So there's an alternative way of doing this. So let's first undo this cell part 2. So I'm selecting everything in part 2, I'm deleting it. Control A, select everything, part 011. So I'm putting it back into the full part. That was Control T. It's a bad key to press because it toggles between structure with text, just the text, just the structure. So if you hit this by mistake, then sometimes the structure disappears and you don't know why. So Control R is what we want. Now we've got too many lines. Lines 12, so we're hiding some of those lines again. Right, so what we can do, rather than modeling this separately, we can actually use the whole thing. We can select the whole entity we'd like to have modeled as disordered, and go over to the toolbox work and down into the disorder tools, and we can just use the split tool with all of these defaults, and now we can just pull the whole thing over. So we're pulling it over into a second position. Control M, we can switch that on in the ways. It'll be a bit too far over. You see, the problem is this is going to be right in here, but if we put this further over, then these carbon atoms will be on top of each other, and if that happens, then OLX2 is going to end up deleting some when they're too close. So let's just try to align this in this way, and that's probably good enough. And refine 12 cycles and see what happens. So this may give us a stable refinement. It looks like it's not too bad. These ones look like maybe they are swapped over. So if that happens, you can effectively fix that by pulling them where you want them. So this one over here, and then also aligning them. It's not cheating as such. It's just getting them into a right starting position. So maybe you want this out a little bit further. So give it a good chance to actually settle by itself. And I think this might happen here more or less. It comes together again. It's a bit strange. Anis, make everything anisotropic and refine that. And now the ADPs are of course causing correlation because we're refining two objects which are very close in space. So the way to deal with this is to press Control H, so that hides the hydrogen atoms. Look at just show P 0 and 1 and select that disordered part and type Regu, put the Regu restraint on that, and then 0 and 2, and do exactly the same here. Just put a Regu on that, and hopefully the Regu is going to pull this right. Now this does not look like a very healthy six-membered ring. Again, it's not unsurprising because we are refining all of these objects very much close in space. So one thing we can do is restrain them by selecting all 6 carbons, and R rings is the command, R rings, and then what have you got? 1, 2, 3, 4, 5, 6 carbons. There could be a nitrogen in there or something else, so this is how you can put that in. So this puts the defix, SADIs and FLUTs in there to keep that ring sane, and we do exactly the same to the other one as well. I think we need to actually align, click them in order. So I'm selecting these 6 in order and repeat the command. So hopefully this keeps those hexagons happier. The fluorines, let's just check out whether they've still got this strange sort of crossing over here. So let me just cross it over properly. So I'm going fit. I'm going to move that over there and that over here. And no, that's not what I wanted to do. Let's just go back. So this over here, and hopefully they'll sort themselves out and go into a sensible position. Yes, they do. Okay, so this is not looking too bad. The R factor is quite a lot higher than it was before. Now I suspect, why is that? Is it higher? Am I not seeing this right? Let's go back in. Oh no, it's coming down again. So the R factor is coming down again. Right. So this is an alternative way to model that. I'm not entirely sure whether I would advocate this. It's a little bit over engineered in a way, and it's also not settling, but it is settling eventually. Of course, we now may end up with funny angles here, so those two are very, very close together. Cell minus L. Okay, so this is 1.46, 1.52. I suspect the way to go about this is to select them and make this part 011, so I just have one. It deleted a hydrogen here because it didn't like the connectivity after delete, and presumably now that one's still fine. And refine that again and see what we end up with. 3.77. I think that's acceptable. That looks fine. Control R. Yeah, to be honest, in this particular case, I would probably go with the other model. It's not settling. Oops, refine. It's not settling very well. It's a bit over refined here. It's too many parameters. We're looking at 8.14. It's just at the border. Okay, yeah, but if that's a model that you would like, so we go cell part 2, cell atom bonds, and we haven't selected those two, so we need to do this manually at the moment. And then group minus n equals, I've something that I've defined that makes it this semi-transparent, and then clear, so we don't have a background, so we have a picture, an alternative picture of this molecule. Thanks for using Olix 2.